is a type of question where quite a number of people are still missing the first step. 2 raised to the power of t equals t raised to the power of 4. Then we're gonna find what the value of t is. Of course, what I've seen quite a number of people doing is to apply logarithm to both sides of the equation, and trust me, this is not what you really want to do. Where the first problem is going to come from is what we are looking for is at both sides of the equation. And if you say you're going to have it this way by bringing your t to this side, then having log of t raised to the power of 4 over log 2, trust me, you're still heading to nowhere. One secret thing about the mathematical question is just the first step. If we get the first step correctly, trust me, there is 100% of getting the answer correctly. Therefore, what we're going to do as the first step now is actually we're going to eliminate one of the t's in which the exponent t is easier. We have 2 to the power of t equals t raised to the power of 4. Considering the left hand side of this equation, it is easy to eliminate this exponent t by multiplying by its inverse. That is, if we have t, then the inverse of t is 1 over t. So this is fraction, the fraction, so t goes there, so we have 1 left. So at the end of the day, we have achieved our aim here. I said that we're going to do the same thing to the right hand side of the equation, because in mathematics, whatever you do to one side, you just have to do it to the other side. So by this, t equals 4t, then we're going to multiply these together, 4 times 1, and we're going to have 4 over t. This is fraction, we make this looking like fraction also, so we have 4 over t. That is 2 raised to the power of 1 equals t, but this time around it is 4 over t. The aim of this is that the value of t that we are looking for, the whole stuff of t is at one side rather than being spread at both sides of the equation. So it is easy to say t equals to something rather than having it here at the same time. You don't even know which one. So the next thing we're going to do as step number 2 is just to cancel figure 4 at the right hand side. Of course, if I'm able to achieve this, that is eliminate this, or at the end of the day I'm going to have only t's at this right hand side, then any other thing in terms of figure is going to be at the left hand side. So if I must do inverse of 4 is going to help me to achieve that, so I'm going to multiply that by its inverse, that is 1 over 4. Then I carefully do the same thing to the other side, that is multiplied by 1 over 4. 4 goes there, that is 1, 4 goes there, 1. Then I multiply this, I have 2 raised to the power of 1 over 4 here, then I have t raised to the power of 1 over t. 2 to the power of 1 over 4 equals to t to the power of 1 over t. Actually, it is glaring and clear that the unknown variable is at the right hand side, then any other thing is at the left hand side. And this is going to be easy for me to equate and suggest what the value of t is going to be, since I have the whole stuff at one side here, making it easy. And the next thing I'm going to do now is to rewrite what is at the left hand side for the same format of what is at the right hand side. This is what I call step number 3. Rewrite 2 raised to the power of 1 over 4 in the format of t raised to the power of 1 over t. And that's exactly what I'm going to do. What I'm saying in essence is that as we have t as a base, then we have 1 over t as the exponent, and the inverse of the exponent is t, the same thing as the base. So we need to write whatever the base that is going to be here to be the same thing as what the power that is here, the exponent that is here, that is the denominator of the power, has to be the same thing. So we're going to be rewriting this and see what we're going to have. The manipulation we're going to use here is to say 2 raised to the power of 1, the imperatives separate the power, that is 1 over 4. As it is, we can say 2 raised to the power of 2 over 2, which is still the same thing as 1 over 2 goes in 2, that is 1, and 1 over 4 previous power is still there, and this could be written as, that is 2 raised to the power of 2, then put this in parentheses, then we have 1 over 2, which is 2 times 1, that is 2, that is the same thing as 2 over 2, then the previous power, which is 1 over 4, is still there. Now if we multiply this together, we're going to get 1 over 8. Then if we multiply this, that is, we're going to have 4. Now we have 4 raised to the power of 1 over 8. This is still equal to the right hand side here. We can also rewrite 4 in this way. 4 raised to the power of 2 over 2, which is the same thing as 4. Put this in parentheses, then we still have 1 over 8 there, in which this can also be written as 4 raised to the power of 2. Put this in parentheses, that is, we have 1 over 2 outside, then multiply by 1 over 8. So we're going to continue doing the same thing here. Multiply this together, that is going to be 1 over 16. Then 4 raised to the power of 2, that's going to be 16. That is 16 raised to the power of 1 over 16. And we still have equals to t raised to the power of 1 over t. At the end of the day, we can see that t is just equals to 16. This is the final answer. And just before we go, we might need to check this value of t to be 16 if it is actually correct by going back to the question and insert 16 wherever we find t and confirm if the left hand side is just going to be equal to the right hand side. Therefore, to verify this, I write 2. So instead of writing t here, I'm going to insert the value of t, and that is going to be 2 raised to the power of 16 equals to t raised to the power of 4. So instead of writing t here, I'm going to write the value, which is 16. Then I have to the power of 4. I put the 4 here. Then I check 2 raised to the power of 16 by calculator. I have 65,536. Then by the same calculator, 16 to the power of 4 gives me the same thing, 65,536. For the fact that this left hand side is just equal to this right hand side shows and prove that the value that is equal to 16 is correct. Just before you go,